All right, guys, we're going to do a short extension on what we learned at the beginning of the week or the previous lesson. So we're going to be looking at equations versus inequalities. We learned how to solve for both equations and inequalities. We're going to delve in a little bit deeper to start about what is the differences between an equation and an inequality. So the obvious difference is their appearance. An equation has an equal sign, inequalities is less than and greater than. But what it represents is how many solutions there are. So for an equation, for now, it's going to represent one solution. So they will look like x equals 7, your final answer, or x equals -4. Inequalities, however, represent a set of numbers. So for example, if we're looking at our less than symbol, x is less than 7. All right. That entails all numbers or includes all numbers that are smaller than 7. So 6 is a solution. 5 is a solution. 0 is a solution. -1/2 is a solution. There are multiple solutions because of the inequality. If we look at greater than or equal to, if we have x is greater than or equal to -4, there are multiple solutions. So -4 is a solution, and so is all numbers that are greater than -4. So -2, 0, 5, 7, and so on. Representing that with a graph is also going to look a bit different for equations versus inequalities. So since an equation represents one answer, we're going to represent the solution with one closed dot. So for x equals 4, we're going to go to 4 on the number line and simply make a closed circle. That way, as you can see, the location is at 4. So the solution is 4. Same with y equals 2. We go to the location of 2, draw a dot. Z equals -5. We represent that with a closed dot on -5. It represents one solution. Well, when we graph inequalities, we need to represent multiple solutions. So it starts off the same. We want to locate where -7 is, so I go to my graph. However, it is not equal to. So because there is no equal to sign underneath, that means -7 is not a solution. So I need to show that the difference, and that difference is creating an open circle. That means that -7 is not equal, or it's not within the solution. I also need a way to show all numbers greater than -7. Well, -6, -5, -4, -3, all the way to 10 are all greater, and every decimal in between is as well. So I'm going to shade in the direction of the bigger numbers or the greater numbers. For C is less than or equal to 4, since 4 is included because of the equal sign, I'm going to draw a closed circle at 4. I also need to include all values less than 4, so the 2's, the negatives, the in-betweens, and shade in the direction to represent the lesser numbers. So to sum that up, we're going to use an open circle when we come across the symbols of less than or greater than. And graphically, we represent that with a circle that is not filled in. Closed circles are used when an equal sign is there. So less than or equal to, greater than or equal to, or simply equal to. That's represented with a closed filled in circle. Now we only shade for inequalities. We do not shade for equal symbols. So for our less than or equal to symbols, right, we're going to shade the lesser values If we are looking at greater than or equal to, we shade towards the greater values, which is on the right hand side. So let's look at what we did last week, the last lesson, and solve, and we're going to take it one step further and graph. So we know that our goal for solving equations is to isolate the variable. So I need to isolate x by using the inverse operation of subtracting 7. The opposite of subtracting is adding 7. I will balance my equation by adding 7 to both sides, and I have x is equal to 4. Because there is an equal sign, I'm going to have a closed circle, and since it's an equal sign, there's only one solution. I will represent one solution with one dot on 4. Even with inequalities, our goal is to isolate the variable of x. Negative 2 is pinched right beside x, which means we're multiplying. So I'm going to do the opposite and divide by negative 2. I have to be aware that I am dividing by a negative value. So because I'm dividing by a negative value, my inequality is going to get flipped around. So instead of less than or equal to, I'm now greater than or equal to. So x is greater than or equal to 7. Once again, we're working with a greater than or equal to symbol. Therefore, I'm going to have a filled in circle, and I need to represent all numbers that are greater than 7. So 8, 9, 10, and all values to the right. Let's just flip this around so we have a different viewpoint. So I'm going to have 2 is less than x divided by 3. So remember, this fraction bar is division, so we're going to do the opposite, use the inverse operation, and multiply. So I'm going to multiply both sides by 3. 2 times 3 is 6. My inequality does not need to flip because I multiplied by a positive number. So 6 is less than x. I like to rewrite this, and the reason I like to rewrite it is for when I go to graph. So I read this in terms of x. X is greater than 6. Instead of saying 6 is less than x, because there is no equal to sign, I have an open circle at 6, and I am going to shade all values greater than 6. Done and done.